Hey guys, what's up? It's Trix. Welcome back to another Learning Rust video. Today we're going to be doing 3 more exercises from the Exercism learning path for Rust. And let's get right into the video. So today we're going to be doing leap, nth prime, and prime factors. So this is given a leap year, report if it is a leap year. The tricky thing is that a leap year in the Gregorian calendar occurs on every year that is evenly divisible by 4, except every year that is evenly divisible by 100, unless the year is also evenly divisible by 400. That seems fine. So all we do is, if year mod 4 equals 0, if year mod 4, then on every year that is evenly divisible by 4, except every year that is evenly divisible by 100, if year mod 100, then we need to check if the year is divisible by 400. If year mod 400, then we need to return true, otherwise return false, return true, otherwise return false. So if I run this, year mod 4, unnecessary parentheses. Oh, do I not need the parentheses? Crazy. Okay. Year mod 100. Year mod. Just need to add spaces. Or true. Year bool expected found U64. I need to do. That's a bit annoying. Run tests. Test failed. Century. True, false. Why is that? Test year, there's a 100 but not by 3. It's still not. Let me see what other people have done for this, because this should work. Solutions. On every year that is evenly divisible by 4, year is. Oh, whoops. I was thinking, what the fuck? So this one uses a match. So that's what I had, but this is just doing a match. So let me see. 4 years ago, match year mod 0 0 0, otherwise false. That is smart, but the logic is like, why? Return year, match year. Okay, I'm gonna do this one. No. This one? Match on year, right? Say it's a case statement where, so return this case statement, but basically all you're doing is year if year mod 400 equals 0, true, right? Year if year mod 100 equals 0, false. Year if year mod 4 equals 0, true, and everything else should return false. Submit. Nth prime. Given a number and determine what the nth prime is. By listing the first 6 prime numbers, 2, 3, 5, 7, 11, and 13, we can see that the 6th prime number is 13. If your language provides methods in the standard library to deal with prime numbers, pretend they don't exist and implement them yourself. Remember that while people commonly count with 1 based indexing, the 6th prime number is 13. Many programming languages, including Rust, use 0-based indexing. Use 0-based indexing for your implementation. Okay, so given a number and determine what the nth prime number is. 0th prime number. Okay, so count let mark count equals 0, right? Then I would need to do for I need to remember for loops again. For loop Rust. I bloody hate for loops in different languages. In like C-based programming like Java and stuff like that, loops are easy. You just do for condition and then the condition with semicolons. But this is like, what? For n in, okay. For n in 1, no. For ooh, I don't even know actually, because you're gonna have to loop. Oh, you use a while. While let I equals 0. While I while true. Right? Let's just do a while true. While true. If let I equals 0, if equal 1, no, it always starts at 2, innit? 2. If I mod wait, hang on. Now you know what, I'm just gonna do the solutions because I know there'll be like a smart solution that I could maybe like understand better. That mark primes filter. Okay, so let me say this. Dot nth. Okay, so hang on. Let map prime, so this just makes a vector variable that is of a predefined, of a like expandable length that only takes undefined 32-bit integers. Then you iterate from 2 up. That's what I was missing. Okay, you filter the candidates, you filter each one and access the actual unsigned 32-bit integer if primes dot iter dot any I dot I candidate modulus I equals 0. What the hell? I want to find one that's like let muts 2 3 while primes then less than equal n as u size let mut next prime last unwrap plus 2. Okay, no. So this iterates through the prime numbers and checks if any of the prime numbers in the primes list is, and then okay, it accesses the integer in the primes array, and if the candidate you currently have, so the possible prime number, is divisible by one of the values in the prime array. If it's not divisible because it has a not here, then push the candidate into the primes array and return true, otherwise return false, right? So it keeps doing that for each number up till whatever, right? So if there's, let's just omit this bit, it will just keep continuing to do this, right? Then all it does is it goes to n, the nth function again, calls it again, and then the n as u size. I don't know why it's doing a u size instead of a u32. Did this person change this to u32? No, it's a U size. N as U size. Oh, so I'm assuming that this just does it until N, right? So this will just continue to do this until it's N. Until N. So that this vector doesn't escape the size of N. And then unwraps. I don't know what this unwrap function does again. Markers complete. Confirm. Show me more. Prime vectors. Compute the prime factors of any of a given natural number. A prime number is only evenly divisible by itself and 1. Note that 1 is not a prime number. Our first divisor is 2, 2 goes into 60, leaving 30, 2 goes into 30, leaving 15, 2 doesn't go cleanly into 15, so the next divisor 3, 3 goes cleanly into 15, leaving 5, 3 does not go cleanly into 5, the next possible is 4, 4 does not go cleanly into the next possible is 5, 5 does not go cleanly into the next 1, so now you're all the way down. 2, 2, 3, and 5. Huh. Okay, so you have N. First you wanna... Okay, so 4, 2, right? Dot. Solutions. This one. While n is greater than 1, let x equal candidates dot next dot unwrap while n modulus x equals 0 and divided equals x factors dot push. Then return factors, and this just returns a vex 64. Okay. Match 2 to n plus 1, find x mod. Okay, this sum x 2 result dot push x. Result that append and factors n divided by x, and none for that, and then return result. This one looks more interesting because it has a match. These two are essentially the same. Because it just has a vector, a new vector array, then you're using a while loop to iterate through all of them. It's just that the find, this is using find, and then this is just iterating using next. So this is using the spread. So these two have similar operations as spread, but these both use a while loop to iterate through each of them. I actually don't know why this is using a while loop if it's using a spread here, because this makes more sense if you're using a spread, because you're going to match each element in the spread. So hang on, let me explain this. So you have a mutable variable called result, which is just a new vector object that's an array. Then you want to match 2, and then you iterate up to n plus 1 so that you're including n as well. You're finding the value of x, which is just the actual number from this iteration, and then all you're doing is dividing n, the number that was passed to the function, by any of the numbers that are in this iteration, and checking if it's divisible, and return and has no remainder. If it doesn't have a remainder, then all that does is, if this is satisfied, it goes through to this anonymous function. It's not really an anonymous function, it's just a match statement, which has like case statements. So all it's checking is if some x, so if this does return a value for x, then all you got to do is push the value that was in here into this result array, and then append n divided by x, because you know that this will return 0, so I'll have a smaller value next, right? So you just do it again. So you'll call this function again and continue to keep iterating through here using recursion until you get to a value that can't be divisible. Like here, 5 does go cleanly into 5, but 4 does not go cleanly into 5. Next possible factor is 5. Then 5 does go cleanly into 5. So we'll keep doing this until you hit 0, basically. And then when it hits none, so if it has none, it will just return none, right? This just returns this. This doesn't even return anything. It just keeps going through here. Whereas this just says, oh, has nothing, right? And then it will just return result. If this has nothing throughout the whole thing, then it will just return an empty vector array. Otherwise, it will return whatever happens in here. With the recursion, it will just return a full list of elements that are in this vector array. So if you run test, sorry, and submit, mark as complete, confirm, show me more. Okay, and I think that is 3. 1, 2, 3. Yeah. So again, quite short, but I am learning as we're going along. It's just when it comes to spreads and like specific logic, I don't know why, but I can't think of it. Like this and this nth prime one, what I would normally do is I would for loop over, no, I would just do a while loop that goes until infinity. And then all it would do is have a count, check if you do have a possible candidate for like the number modulus whatever. So it would be, if the count is 2, it will do, what's it? Prime, it will just do 2 mod I, 2 mod n, and then mod n divided by 2. N mod n, to check that it's, no, it will just be number divided by, and then you'd for loop over half the values that, and half of the values that make up n. Say for example you have 10, you would have you would do a for loop for 10, right? But you'd only for loop up to 5. So you check if any of those values of that value divided by 2 is divisible, makes it divisible. So if you have 11, you'd do half of 11, so you do 5 up to 5, because 6 doesn't go into it fully, and then you just iterate over that from 1 to 5 to see if 11 is divisible by any of those numbers. Because it's not, you just return that that's true and add it to the primes array. Otherwise, say for example you have 10, you do the same thing. You'd iterate from 1 to 5, see that it's divisible by 2 and 5, and say, oh, that's not a prime number, so you return false instead of adding it to the array. Because for loops are weird in Rust, I'm just assuming that the spread operator is a lot easier to use. That's why I got confused there. And then with this prime factors one, it's similar. It's just because you're using this instead of a normal for loop. If this was like Java or something, it would be easier because you could just make a for loop and handle the logic yourself. It's just in this, it's a bit weird. Other than that, I feel like I'm understanding a lot. Like this was just me being like, I know there's a better way to do this, because Rust has match statements. In Java, you do have switch cases, but most of the time switch cases have too much syntax for you to actually use it in a like decent, like concise way. Even this, like using a match statement, but you're still using if statements, it would have been better to just use if statements and then have the white space to make it more readable. Whereas this, yes, it's more concise, but it's less readable if you're not used to the language. If you are used to the language, it's probably easier to understand it. But like if you don't know that this is like a default statement, then you'll just get confused when you're coding like this. But other than that, yeah, I feel like I am learning Rust decently. Sorry about that. But yeah, if you like the video, please leave a like on the video. If you dislike the video, please dislike the video and comment down below ways that I can improve to make your viewing experience better. But other than that, subscribe to the channel and have a nice day. Peace.